All right, number 15, I'm asked to solve the inequality, put it in set notation, interval notation, and actually sketch a graph. So I got a couple of things I want to do. I'm trying to solve for x, and I noticed that 3 on the outside. I could distribute it in, but I want to get x by itself. So the first thing I'm going to do is I'm going to go ahead and divide by 3. And that'll leave me with 1 plus x is less than or equal to 2. And then I'm going to subtract the 1 off of both sides. So I get x is less than or equal to 1. And so there's one of my answers. So in set notations, it's x such that x is less than or equal to 1. Interval notation, that would be negative infinity up till 1 with a bracket. And then on a number line, sorry, getting ahead of myself here. On a number line, I would have a closed circle at 1, and I'd be shading everything to the left of it. So those are the 3 forms of that answer. Okay, number 16, we have a 3-part inequality. So the idea here is whatever I do to one side, I have to do to all 3 of them. Now I see I've got some fractions that I need to clear up here. So I need to find a number that I can multiply a half by and a fourth by to get rid of the fraction. And so what's the biggest denominator that both 2 and 4 go into? Sorry, the smallest number that both 2 and 4 go into, then phrase it like that. And that would be 4. So if I multiply every single side by 4, that would completely eliminate the need to have a fraction. So here I get half of 4, which is 2. There the 4's divide out in the middle, so I'm left with x plus 3. And then 3 times 4 is 12. Then I want to subtract 3 from all 3 sides. So negative 1 is less than x, which is less than 9. Okay, so there's one of my answers. So x such that negative 1 is less than x, which is less than 9. Then in interval notation, it would be open parentheses negative 1 to 9. And on a number line, I would have open circles at negative 1 and 9, and I would be shading everything in between. Number 17, we got to remember what our rules are. So we're looking for the symbol and the sign. So the fact that it's less than 6, so less than means I'm going to translate it into a 3-part inequality. And that's positive 6, so I can do that. So negative 6 is less than x minus 3, which is less than 6. If it was greater than, then I would have the or statement. So I'd have that x minus 3 is less than negative 6, or x minus 3 is greater than or less than 6, I'm sorry. Anyways, so now I've got a 3-part inequality again. I'm going to add 3 to all the sides. And I get negative 3 is less than x, which is less than 9. And so that's one of our forms of our answer. So x such that negative 3 is less than x, which is less than 9. Parentheses negative 3 to 9. And then on a number line with open circles, I want to shade everything in between. Okay, number 18 is sort of one of those trick cases, so you want to be careful on how you read this. We're given the absolute value is greater than a negative 10. Okay, so this fact that I start off with a negative on the opposite side of the absolute value tells me it's one of my special cases. So I want to think for a second what this means. Well, absolute value is a positive thing. Whatever x is, whatever I plug in there, I'm going to get a positive number out of this. And I'm being asked to compare it to a negative thing. Well, how many times will a positive thing be bigger than or equal to a negative thing? And that's always. Okay. Had the symbol been less than or equal to, then we would have said no solution. So you do want to be careful about the symbol and the sign. All right, number 19, we're asked to find x and y intercepts off standard form. Nice thing about standard form is I can use what's called the cover-up method and figure out where they cross the x and y axis. So let's pretend we're solving the equation 4x equals 16, in which case x would be 4, which means it crosses the x-axis at 4. So 1, 2, 3, 4, right there. Okay, do the same thing. Negative 8y equals 16, and I get y equals negative 2. So it crosses right there, and then I just draw a line connecting those 2 points. And there we go. So that particular one is done. In number 20, I'm asked to write the equation in slope-intercept form given those 2 points. Okay, so my first task is to remember the slope formula. So the slope formula is y2 minus y1 over x2 minus x1. And I am just going to pick one point as my first point and one point as my second point. And it doesn't matter. You just need to be consistent about which point's your first and second. So 9 subtract a negative 1 up top, and negative 7 subtract 5 in the denominator. See, that gives me a 10 in the numerator and a negative 12 in the denominator. And that reduces down to negative 5, 6. All right, then I want to use point slope form to set up my general equation, and then I'll manipulate the form to get it to look like slope-intercept form. So again, I'm just going to pick a point, and since I've already got it set up for y1 and x1, I'll just use that 5, negative 1. So it's y minus a negative 1 equals negative 5, 6, x minus 5. Well, obviously that's plus 1. And let's bring that over. So let's actually distribute 2. So negative 5, 6x plus 25 over 6. And then we're going to subtract the 1 that was on the other side as a plus. It's now a minus. And then we'll simplify that. So negative 5x, negative 5, 6x plus 25 over 6. We're going to rewrite that as 6 over 6. And 25 minus 6 gives me 19. Okay, so my equation is y equals negative 5, 6x plus 19 over 6. Okay, so just a caution as we look at word problems here. I don't want you to think that because I've only picked these types to show up on the review, that these are the only ones that are fair game. I tried to give you a snapshot of different topics that we've encountered in this first unit. So please make sure you look over all of the different types of word problems and how to set them up. Anyway, so this first case fits under the linear category. Sandra's paid time and a half for the hours worked in excess of 40. She earns double time for hours worked on Sunday. She earned $5.45 last paycheck. She also worked 3 hours on Sunday and for a total of 58 for the week. How much was her regular pay? Okay, so we have kind of set up a little chart here. We have regular. We have time and a half. And we have double. And then we have total. All right, well, total, we know is $5.45. That's how much she made. I know she must have worked 40 hours. I don't know how much she got paid for it, because I know she worked a total of 58, so I know there's 40 there. I know it was 3 hours in the double, and she gets paid twice as much as her regular wage. So time and a half would be 1.5 times her regular wage. And then how many hours are left over? Well, I know, kind of off to the side here, I know 40 plus 3 plus some other number has to be 58, because I know she has to have made 50, worked 58. So I can kind of work backwards. So 58 minus 3 is 55, minus 40 is 15. So I know she must have worked 15 hours at time and a half. Okay, so then from here, we just have a good old-fashioned equation. So 40x plus 1.5 times 15 is 22.5x, plus 3x is 6x. Let's see, so 22.5 plus 40 plus 6 is 68.5. X equals 545. And then I want to divide that out. Alright, so 545 divided by 68.5. And I get 7.9. There's actually several decimals here, but honestly I just made up a number, so I didn't promise it was pretty. So we get 7.96. So she's making 7.96 bucks an hour. Doesn't have to be realistic, but according to the numbers, that's what she's getting paid. All right, number 22 is an area type problem. So let's see, the area of an opening of a rectangular window is 143 square feet. So I've got a rectangular window. It's got a length and a width, and I know the area is 143. If the length is 2 more feet than the width, okay, so we'll say the length is the longer one, so the shorter one's got to be x, and the longer one would be x plus 2. And so together that should multiply to give me the 143. So our formula is x times x plus 2 equals 143. So I get x squared plus 2x equals 143. And then we'll move this over, so x squared plus 2x minus 143 equals 0. Okay, so the hope here is that it's a factorable expression. So we'll kind of look. Let's see. I know 1 and 143. I know 2 does not go in there. 3 doesn't, 4 doesn't, 5 doesn't, 6 doesn't, 7. So I'm going to try that in a calculator. Nope, 7 doesn't. 8, 9, 10, 11. All right, we'll try 11. And 11 and 13. Oh, wait a second. I think we just found it. Because there's a 2 in the middle. And so I want the 13 to be plus in the factored form and minus in the 11 to be minus. And so that gives me x is positive 11 and negative 13. So in context of this problem, it does not make sense to have a negative 13 length or width, so that doesn't make any sense. But I can go back up in 11, and conveniently when I plug 11 in, I also get 13 for the other number. So the dimensions are an 11 by 13 rectangular window. 11 feet by, sorry, feet. 11 feet by 13 feet. A nut store normally sells cashews for $7 a pound and almonds for $3.50 a pound. At the end of the month, almonds had not sold well. In order to sell 50 pounds of almonds, the manager decided to mix the 50 pounds with cashews to sell the mixture at $6.50 per pound. How many pounds of cashews should be mixed with the almonds to ensure no change in profit? Okay, so this is a mixture equation. So I've got 2 giant containers that I'm going to mix together to make a larger container. Okay, so I know that there's a $7 per pound one and a $3.50 per pound one, and I want to mix those to get $7.50. Do I know how much? I see the number 50. So what does a 50 represent? 50 is connected with the almonds. And I don't know how many of the cashews, so I don't know how many of the $7 ones I want to mix together. But when I'm done, I should have x plus 50. So my equation then is going to be 7 times x plus 3.5 times 50 equals 6.5 times x plus 50. And then I just want to solve that. So let's see, 7x, 3.5 times 50 is 175. And that's 6.5x plus 6.5 times 50, which is 325. Let's see. If I subtract off 6.5x and subtract off 175, I should get 1.5x equals, and then 325 minus 175, which is 150. And then we'll just divide. So 150 divided by 1.5 is 100. Okay, so they must have added 100 pounds of almonds. I'm sorry, how many pounds of cashews should be mixed? So 100 pounds of cashews to mix with the 50 pounds of almonds to balance this out. All right, and in number 24, we want to set up a little chart here. So we want to figure out up versus down. We want to look at any relationship in distance, rate, and time. Okay. So problem says motorboat heads upstream that has a current of 3 miles per hour. The trip upstream takes 7 hours. Okay, so up is 7 hours, and the return is 4 hours. The distance actually is going to be the same for each. The rate. Okay, so the boat is going a certain speed, and either water is working for it or against it, right? So when it's going upstream, that current of 3 miles an hour is going to slow the boat down. So in this case, it's going to be x minus 3. When it's going downstream, it's going to make it go faster. So it's going to be x plus 3. Okay. And the formula that we're going to relate this all with is distance equals rate times time. So I want 7 times x minus 3 equals 4 times x plus 3. And then I just need to solve that. So we'll distribute 7x minus 21, 4x plus 12. Oh, let's see, we'll subtract off 4x from each side. We'll add 21 to each side. So that gives me 3x equals 33. And so when I divide by 3, I get that the boat must be going 11 miles per hour? Miles per hour. And there you go.